Okay, so these slides are a little bit stale now, but the quiz number one, Joey, and I think there were a few other people in that right now who convinced me to move to Wednesday. I'm going to try to never let that happen again. I think it would have been fine to do it on Monday. I do have that first homework assignment up, and that includes some problems from section 1.3, which is what I have for you here.
Definitely prepared for this class.
Do the homework.
Okay.
Is it like an essay?
No, it's just about math stuff. Like, and frankly, it's arithmetic, except ancient arithmetic. That's why they need two more. There you go. Did anybody else not get one too?
So the quiz is on Wednesday?
Yeah. I feel like I'm getting everybody all excited about this quiz. It's going to be really sort of stupid and I don't really super think of it.
So is the homework still
This is
on
1.2.
Monday?
1.2?
1.2, I got it from.
I need one.
You didn't have one. That's my originals.
When's the next one?
So Monday or now Wednesday?
Hey, I'm not going to check it on Wednesday when we have the first.
There's another homework.
I can't believe how late you guys are because I was late and then
That's the one that's the one this is today though.
It's 2 weeks from now.
I didn't know I should think Monday, so this is
Oh, that's
one. I'm going to actually get to that in a second. Also, by the way, that thing you showed me about the tree,
Yeah.
that was cool. I mean, like, I got stuck in a loop watching the video. I couldn't.
Me too. Yeah. They got those shapes.
Robert shared, just one of these meme type videos you see where it was a machine that creates cookie cutters. So you ever see a Christmas tree cookie cutter? It was the thing that makes those. And it asks there's an interesting math question there. How do they work out the perimeter of sort of the outside of the cookie cutter shape before it gets formed to the shape of a Christmas tree, something really irregular? Okay, so did you get one? At least one thing? I think there's enough wiggle room in there that even if it wasn't perfect, they could.
I got one already. So you did move the paper from Monday?
I did. It's a Monday now. Yeah. So let's.
So the paper?
Yeah. I was talking about this whole slide being wrong now, but I didn't want to change the slide because I'm working on the same slide from Wednesday. So quick review. The homework says it's due Monday. Not going to check it till Wednesday. The quiz will be Wednesday, and the second paper, of the Babylonian tree controversy is, if you've got it done today, that's great, but you can take the weekend to hone it if you like.
So we're still submitting it through CodeCalc, which we all have gotten in.
So let me go into CodeCalc for a second. We'll talk about that. So yes, CodeCalc. Here we go. seen this red banner, if you go into it. Anybody let me know if that is still what you make this one. That's what, I forgot to upgrade my own project. So I guess how do I say this? You should get familiar with how to navigate in CoCalc. I think this is where the slightly kludgy thing about the interface. So you've got multiple tabs here, and you've also got multiple tabs at the top of the screen. The top level tabs are the projects you're working in, which is why it has that heading. But once you're inside a particular project, these are the sort of navigation things. But most often, you're going to be using the files tab, meaning you're looking at the contents of your folder. Within your folder now, you should see one that looks like this, paper_2. Underlying this whole system is a Linux environment. Has anybody ever played on the Linux computers before? So file names that people are used to in Windows, file names can be pretty much any text you want. But Linux works on a command line basis, and the command line distinguishes the pieces of a command by spaces in between them. So spaces in a file name look like you're talking about two different files to a Linux system. Does that kind of make sense? So try to avoid putting spaces in your files. Most of the time it will figure that out, but I've seen this a couple of times where weird behaviors were troubling people, and it turned out it was just a funny file name that some low-level Unix team was breaking things because it didn't recognize the space properly. So that's why I do things like paper_2 or sample underscore bib. Anyway, what you should see in your directory when you click on the HoM project is just a folder with paper2 in it. Now, you may have put other stuff in there yourself, right? But just you need to move whatever you put elsewhere into that paper2 folder. So how do you move stuff? This is what I think is very non-intuitive. If I wanted to take this sample bibs.pdf and put it in there, I select it, click on the box, right? And then look at these options that show up. You can move things. So I can move it to, and in fact, it'll give me the options of different places that are available to move it to. So I can stick it into paper2. That was weird. It said paper2 twice, and one of them was clickable and the other was not. I don't know what that was about. But now if we go inside of this thing, you'll see it's missing. What did I just do?
You didn't move again.
I didn't click it? Oh. Still me. Okay, so now, wait a second. I'm not seeing the view. I said, hey, files was our navigation, and inside of files, but now the view of the things has changed. Why is that? Or how do we get back to where we were a second ago? Notice this little navigation script up here. This is like, we want to really be in that house, not in paper 2. We can just click on that and go back.
We used this in Calc 1.
Sorry?
Did we use this in Calc 1? Like 3 years
In my class?
Yeah.
I think we may have. Yeah. Do you have some Calc 1 stuff in there?
No, I have an account, so I was like, I've never made an account.
You need an account to
But-
write your paper in this class when we were in the lab on Monday.
I didn't come to your class on Monday, but
Well, Joey,
but
remember it.
I overslept, but
So you have one?
but I think I have one from Calc 1 somehow.
Or Calc 3? I often use it in Calc 3.
I didn't take your Calc 3 class. I was the semester after,
I can't remember what classes I
because I had like Calc 2.
Use it in
Same.
So anyway, let me try that again. I want to take this this sample bibs.tech and I want to move it to paper 2, and I have to actually tell it to move it, not just select things like that. And now if I go into paper 2, there it is. Now-
Paper 2 is your folder?
Say again?
Paper 2 is your folder?
So paper 2 is a folder I created and then I assigned it to you, which means it copies the paper 2 and its contents over to your guys' directory. Did you say it immediately? It's right at the top level in your stuff.
So if we already did it, it wouldn't show on yours, like you're in student view?
Yeah, I just need you to move it into there, and then when I hit collect, I'll get it.
Oh, you click okay.
Yeah. So that's why I'm showing you how to move stuff. If you move it into that paper_2 folder, then when I collect, they come. you can see, I can kind of show you my interface if you would like. What I'm looking at is the course file, and that has all your names, right? And I can go into assignments. The only assignment we've got is paper 2, but if I hit this blue collect button, it goes out and finds all your accounts and grabs whatever's in that folder and drops it into mine. And I can look at it. And I'll make comments there, and then once I've done comments and grading, I'll return it to you the same way. It'll just appear magically in your paper 2 folder. So back to slides. Well, actually, I should get out of this. Did I give you guys a spiel about security with CoCal? I think I mentioned anything about this. What I would like you to be kind of conscious of the fact that this system gives people, anybody who's on it, a tremendous amount of computing power. I mean, it's a scary amount of computing power. Hackers would love to be able to hijack those hacker accounts and use them to like run password finders and break into other systems and stuff. So be careful about your CoCalc account. Don't have a stupid password on it, and don't leave it logged in when you walk away from the computer. You really are kind of playing with fire here. So yeah, sign out when you leave it. Okay. We already played poker. Anybody who missed the hieroglyphics poker? Oh, what a good time. So we're going to start talking about actual human beings now instead of just general stuff. In the Babylonians and Egyptian periods, we didn't know who the players were. But once we get into Greek mathematics, there's historical records. Most of our records, though, come from a few philosophers who wrote near the end of the classical Greek period, around 500 AD, so about 1,000 years after the people we're starting to talk about now. The people we're about to start talking about, most of the records from them are gone. They wrote on stuff that was not permanent. So I think they had something like rice paper that they could write on, but they didn't chisel it into stones the way the Babylonians did, and they didn't write it on animal hides the way the later Greeks did. So we're missing a lot of original works from this early Greek period. I'm going to talk today about Thales and Pythagoras. I'm sure we've heard of Pythagoras, probably not so much Thales. And then we're going to cover these remaining five more Greek mathematicians. These people run through a span of about 1,000 years. So Thales is about 600 BC, and Hypatia, later on we're going to look at some movies. There's a great movie about Hypatia. Probably the most eminent of the original female mathematicians. She was pretty interesting. So, but there's many more. There's probably another dozen or so. So I said on this first bullet, you can go to the MacTutor History of Math archive. Just Google that and check it out. They've got biographies on lots of mathematicians from ancient Greece to modern day. And it's pretty interesting. You can almost get lost in following links around in there. It's a fun place. So this brings us to our next writing assignment. Even though the second one's not quite due yet, this is going to be coming, so I want you to sort of know about it. The third assignment is going to be a 2-page thing. That's one thing I forgot. There is a typo in the instructions on the. You got it right. On the instructions on the second paper, it says it's supposed to be 1 page long, 25 words. 250. Yeah. I was writing like a Babylonian. I don't have 0, so you guys didn't notice the space after. Yeah, that's my excuse. So the coming assignment is going to be a 2-page paper, again in LaTeX and LaTeX, whatever we say that, about just a bio of any one of these people from the classical Greek period. So it can be the 6 or 7 people we're going to talk about in class, or you can explore on MacTutor and find somebody else that interests you. There's names you'll recognize, right? You'll go, oh, I know that name, I've heard it before, and maybe cruise around and see what you think is interesting. So, one of the data points on that XKCD cartoon about the timeline from the Ice Age to now was the Bronze Age collapse. Nobody quite knows what happened. There were all these really vibrant civilizations going. Babylonians, Akkadians, let's see, Egyptians for one, and then people living all along, the coast where Israel currently is, Israel and Syria, all the way on the sort of very end of the Mediterranean Sea. Turkey is sitting above them. There was just these walled cities all along that coastline that were trading with one another and doing interesting Bronze Age stuff, making bronze tools and stuff. And suddenly, in a span of like less than 100 years, they all went away. Just disappeared. Nobody quite understood why. One theory is, do you remember there was a bit in the history of the entire world, I guess, thing where they were talking about they had crappy metal, they had copper metal, and then they got better metal because they got a secret ingredient from the magic worlds of tin land. Tin added to copper makes bronze, and that's what the Bronze Age is about. One theory is that the tin mines just dried up, and these guys couldn't make their tools anymore. And then these bigger civilizations that had bronze weapons just got mowed down by other guys with rocks. Because they could no longer make the cool weapons that they had become dependent on. Again, that's theory, nobody really knows. But anyway, this is a real thing. Around 900 BC, well, 1000 BC, there's a span of years where it happened. All these Bronze Age civilizations just disappeared. But afterwards, things came back, and you've probably heard of the Phoenicians. And the Phoenicians are kind of led into the Greeks. Anyway, they formed these widespread trading empires. I think calling it an empire is a little bit off, but still they had a bunch of people doing the same activities, and they were identified with one another. Oh, we're all Phoenicians, or we're all Greeks. To my mind, it's kind of the most interesting development there is they figured out how to make really good boats by then. In the Bronze Age, not so much, right? Boats were something that's sort of single-man watercrafts, and often they were just like a bundle of sticks and reeds that you could float on. Paddle around with your hands, right? But now these guys had come up with actual boats made out of, made out of trees that were watertight and had sails on them. They could move around well.
Is that before or after Archimedes?
That's way before Archimedes.
Oh,
Yeah. So after 300 years from the Bronze Age collapse, suddenly people started doing math. And this is way better than the math we're talking about with like the Egyptian writing and the Babylonian writing. They were not just interested in pragmatic issues like figuring out how much area my farmland is or counting how many bulls and sheep I have. Right? It wasn't just accounting, it wasn't just pragmatic stuff. They cared about math for the sake of math. This is indicative of a society that had gotten to the point where they were well off enough that they had sort of space for some people to be just crazy dreamers that thought about wild stuff. Right? That's the sort of society we live in, right? We're pretty excited. I think, if you haven't thought about it much, recognize that you live in a society that sent a probe to Pluto, to the very farthest extreme edge of our solar system, and sent back pictures. That's just amazing stuff, that you have a society where there's the freedom of action, that some individuals can engage in work that has absolutely nothing practical, no practical ramifications of it, but it's just awesome that we can do that kind of stuff. This is kind of the beginning of that level of society where there's general wealth of the society is good enough that some people could engage in useless activities. Useless, I say. So yeah, there was no central government in the Greeks, but there was a bunch of city-states. You probably have heard of there's a movie about Sparta, the 300. Anybody heard seen the 300? That's the kind of organization they had, a bunch of city-states that sort of loosely confederated together. Yeah.
It's kind of a random question, but was there like a religious aspect to early math?
Well, they did have a shared religious cosmos, I guess you would say, right? The Greek gods, like the planets in our solar system are all named after the Roman equivalents. But you know who, like Jupiter, that's the king of the gods, the biggest planet. In Greece, they call him Zeus. It's basically the same. The Romans adopted the same gods and just changed all the names. But they had this pantheon of gods. There's 25 of them. It's actually Greek theology is pretty interesting. They had an original group of gods, and the original group of gods gave birth to children. They called them Titans. And then later, these original gods had another group of children they called the gods. Just gods with a small g, right? So the original gods were Uranus, is, oh gosh, I can't think of his name.
Uranus and Gaia.
It's Gaia is the Greek, but Uranus is the Roman equivalent. So it's, I don't know, it's the sky god and Mother Earth, right? And they have these children called the Titans, and then later they have the children that are the Greek gods that would be worshipped in this period. And there's this whole period, this whole event called the Titanomachia, where the new baby gods kill all the previous Titans, and then put their father and mother in chains. It's a very weird theology, but the strangest thing is that the Titans and the gods are mirror images of one another. I mean, they're like, he's the god of agriculture. No, he's the new god of agriculture. He's the god of war. This is the new god of war. They just sort of had this idea that they had a previous set of deities that were just replaced by a new set of deities. I'm not sure what that says about their social structure, but anyway, that's what they thought. It is interesting that despite this not really being an empire, we talk about people that were Greek going over a period of over 1,000 years. I had an interesting experience a couple of years back. I went to this art museum at Yale. And one of the things in the very lowest level is a big display of Greek artifacts, right? Sorry, Egyptian artifacts. It says Egyptian artifacts. And I go down into this place and I'm like looking at some of the rocks and I'm like, I recognize those letters and those are Greek letters. Right? The Greek alphabet, if you've been on a university campus, you get used to deltas and sigmas. I'm like, that's definitely Greek. What's going on? Well, it was an empire in a sense, right? These Greeks had gone to Egypt and they took over, and so their writing was. I mean, a lot of the people that we'll talk about as Greek mathematicians actually lived in Egypt, or they may have lived in Italy, Turkey. So Greece ended up, being big, not the little chunk that we look at today. Okay, so what's Thales? Thales is known as the father of geometry. 622 to 547 BCE. I don't know that we actually know if this dates that accurately, but that's what it says on the MacTutor History of Math archive. I mentioned already that there's not that much in the way of surviving documents from that early period. The guy's formal name would be Thales of Miletus. That's a city in what's now Turkey. Father, I told you already, is the father of geometry. So Asia Minor, that's another name for Turkey. He traveled to Egypt and then returned to Ionia. Ionia is the Greek name for the province in Turkey that he would have come from. And he was an engineer and a statesman, so meaning he engaged in the political life of that city-state. But he also figured out how to build bridges and roads and things. Proclus is where we get a lot of our information about the early Greek period. But he was writing, Proclus was almost 500 AD. He wrote, Thales first went to Egypt and then introduced this study, and he was talking about geometry, into Greece. He discovered many propositions himself and instructed his successors in the principles underlying many others. His method of attacking problems had greater generality in some cases and was more in the nature of simple inspection and observation in other cases. So when he said he had greater generality, then that's the times when he was acting like a more modern mathematician. He was thinking about axiomatic systems and saying things in general, not just saying, oh, look, here's one case of a thing and I can figure junk out from that. So let me tell you about some of the things he did. He's credited in some accounts with predicting a solar eclipse. And I've seen this in a few movies where somebody knows that an eclipse is going to happen and all the you know, people around them don't know this thing. You impress them with your ability as a sorcerer or a magician by telling them, I'm going to make the sun go out. Right? Yeah, that's probably nonsense. It's unlikely that he had that ability. But you know, that's one of the features of history, right? That people's accomplishments get exaggerated over the years. So they don't think he would have known the kind of geometry, the three-dimensional geometry of the paths of the moon and the sun that you would need in order to predict an eclipse. But he did prove these theorems, and they're good ones. What does this first thing mean? A circle is bisected by any diameter.
The diameter is the longest line.
The diameter is the longest chord you can draw in a circle. Right? Well, what does it mean to bisect a circle?
It's down the middle.
It's cut in halves. They're equal. Right? So you can either think of the circumference of the two semicircles that you create are equal, or the areas of the two pieces are equal. The figures, these semicircles you create by cutting that biggest chord, are congruent. You can move one around until it lays on top of the other. How would you prove a thing like that? Yeah, that's how I would do it. I'm going, well, look, here it is, right? But that's not what they mean by proof. You need to have a good argument. And why is that? I don't know. I honestly don't know what the always proof of that is. If you have an isosceles triangle, everybody good with their triangle nomenclature? What's isosceles mean?
The sides are equal.
And if you know some ancient language, iso means equal. You know what skellies are?
Skeleton.
Sides. Yeah. It sounds like, I mean, it's, I don't know, skeletons, yeah. Maybe they were thinking about, like, you know, you could take the arm off a skeleton and have it with equal arms. Anyway, yeah, so same side. So all three sides are equal. So the base angles of an isosceles triangle are equal. Doesn't that make the third angle also equal?
I thought isosceles was two sides.
So two sides is equal and that's it?
Yeah, isn't it equilateral?
Oh, equilateral, right, okay. So equal sides just means two equal sides, not three.
Right, yeah, that's true.
Okay, so wait a second then.
No, that would make sense, but then it's two angles.
Isosceles is something like this, right? Where this angle is equal. I mean, to me, how I know that is, I sort of think of it this way, that if I draw two equal angles and the third is whatever, I'll get an isosceles triangle. But what the truth is the sides are equal. This side's length and that side's length are the same, and this is maybe something different. How do you prove that this angle and this angle have to be the same, given that? Well, right, if you know the law of sines, it falls right out. If you drop a perpendicular from here, you can get two angles, two pieces that are congruent. Maybe that's how they did it. But the point is, I think the major point here is that this guy Thales was beginning to think about something that most people wouldn't have cared about. They would have just said, yeah, well, you know, look at the picture. Of course it's that way. Right? But he was trying to think deeply about why, underlying reasons, and that's new. That's a new thing in the world. The angles between two intersecting straight lines are equal.
Did they have some sort of like weird primitive formal logic, or was that?
Well, I don't think it was formal, but they did have logic, just because humans do, right? But I don't. Yeah, I think that was before anybody had formalized logic. But people still, you know, they talked and they argued and people could criticize whether a thing made sense or not.
So proofs at that time were just like convincing arguments, basically. Like,
Couldn't hear you.
so proofs were basically just like convincing logical arguments, but not like
Proofs
formal.
have always been
Well, yeah.
nothing more than convincing arguments. Right?
Yeah, but I mean, like now, like you're supposed to. I mean, like it depends on what you're doing, but it seems like a lot of proofs like take advantage of like really, you know, rigid formal logic when
Right.
defining things.
So the first person to do rigid formal logic is Euclid, right? And we don't even know if Euclid is one person, but that's another 200 years from now. So this is before we got to that kind of level of, here's the axioms, this is what we can assume, and then we can reason from there. But still, you know, they were making progress. They were beginning to think about abstract ideas. Do you guys know this theorem? The angles between two intersecting straight lines are equal? If you just draw two lines that cross each other, this angle and this angle are the same. I think that's completely clear. It's another one of those ones where I go, you know, look at the picture, what else could have happened? But that's not an argument, that's not a proof, and Daly's did a proof. I mean, I'd be curious to talk to a geometer like Dr. Finshu or Garrigan and see if they know what Daly's argument was. I don't. Two triangles are congruent if they have two angles and one side equal. Hey, that's trigonometry. That's angle, angle, side. Angle, side, angle. I forget which one. Yeah, it's one of those rules that you know when the two triangles are congruent if they have. Oh, by the way, no. Last one I love. An angle in a semicircle is a right angle. So here's what you do. Here, I don't know what Daly's was thinking. You just draw a semicircle and you put an angle right there. It's in it. It's not a right angle. Case closed. Daly's was wrong. I'm kidding. Okay, so what did he mean by that? An angle in a semicircle is a right angle.
At the corners?
No, not at the corners, but the corners have to be part of the triangle that we're talking about. If you take the corners and connect them to any point on the perimeter, right? Like that, this is what, I mean, it's just not said well, right? But if you start at the corners and go from there to any point on the perimeter, this will be a right angle. Is that surprising? It is cool though, right? It'll always be a right angle, no matter where you put that thing. You could go right angle. You might want to check that out in something like GeoGebra or something. It is true. Again, I'm not sure what Daly's proof was. I don't know if anybody's, like, nothing survived except the mere fact that he did these things. He supposedly wrote a book on navigation. That's not necessarily, it certainly hasn't survived, but there's apparently people thought that he had written that. That would have been really important to these Greeks that were traveling around the Mediterranean. The Mediterranean is an ocean. I mean, it's kind of almost oceany. If there's a storm, you can get in trouble, but it's also a pretty small place too. So navigation there versus navigation out on the Atlantic or the Pacific would be way easier. You could just keep sailing in one direction. Eventually, you'll hit land, and you'll be like, "Hey, where am I?" Just talk to the other people there. But still, navigating would have been an important skill for them. And they say he possibly used the idea of similar triangles to measure heights. Have you guys ever done that? Use similar triangles to measure heights? I give you my favorite example of all time. You have a mountain, right? This is a mountain with snow on the top, and you have a tree. This is a tree. And then you line yourself up so that the tip of the tree and the tip of the mountain are in a line. Now, you've got a triangle here with an angle theta in it. And if you know, hey, you can probably just estimate how tall is the tree, right? You can go, okay, well the tree, and I'm only, maybe I'm 50 feet from the tree, and the tree is 40 feet tall. I got a triangle there. But the similar triangle is, well, how far away is that mountain? And how tall is the mountain? Because it's going to be in the same proportions that the 40 and 50 are. So you can use that kind of thinking to roughly estimate the size of distant things, which could measure directly. All right. So I always like to give you some funny tidbits. This is the lowest sort of humor, though. Basically, I want to make fun of this guy's parents' names. Yogiline. I'm trying to picture Exam Yes. And who has a name like Exam Yes? Yeah, sure, I love an exam. Probably Exam Yes, but I just got this mental image of the two of them, like, making out or something. It's like, Yogiline, your eyes are like dark pools. That name kills me. I don't like it. What else? There's this one story about Thales that comes to us that's kind of, they claim in my tutor it's the first absent-minded professor joke. But I'll just read this whole paragraph to you. It's interesting that both stories, he has stories told about his great practical skills and also about him being this unworldly dreamer. So Aristotle, which I'm sure everyone's heard of, relates a story of how Thales used his skills to deduce that the next season's olive crop would be a very large one. So he buys up all the olive presses and he's able to make a fortune when the bumper crop arrives. That's kind of smart. Well, it's also kind of mean. I got all the presses now. If you want your stuff dealt with, you're going to have to pay me. You've got these huge crops. Anyway, on the other hand, Plato tells a story of how one night Thales was gazing at the sky as he walked and fell into a ditch. And a pretty servant girl lifted him out and said to him, "How do you expect to understand what's going on up in the sky if you do not even see what is at your feet?" Maybe it's not a funny joke, but at least they were trying to. Okay, so that's our next guy. Did I show you the picture that I got of Thales? That's all the way at the beginning. That's, generic ancient Greek guy. I don't think that really is any resemblance to the actual person. That's the picture they have online. That is supposedly Pythagoras. We're more likely to have had an actual image of him made in his time that would have survived, so that's probably what he really looked like. Or more or less. He's from Samos, which is also in Turkey. His father was, this is a hell of a name to say, Nisarchus. You have to do MN, which is not a usual diphthong in English. Nisarchus. There's actually MN like that is common in Greek. Like the god for memory is Memnos. Have you ever heard of memes? You guys have heard of memes? That comes from Memnos. That word is derived from the Greek idea of memory. The mother, Pythes, was also from Samos. Her father was not. He was a merchant who came to that area. He came from Tyre, which is also in Turkey, so that's okay. He traveled extensively and he took the young boy with him. So that's probably pretty unusual. Right? In this period of time, kids would be left with their mothers. It was dangerous to go out on these merchant voyages in the ancient Greek world. So taking his young son with him was an interesting step. They know he definitely met Thales, the father of geometry. Did he study under him? That's less sure, but none of his writings have survived. Nothing that Pythagoras himself actually wrote down has come to present day. And that's partly because they wrote on crappy paper that rotted away. But it's also partly because he created a secret society. More than being a mathematician, this guy was a cult leader. I don't think people realize that. He was literally, he had created this cult that actually became rather politicized. Yeah.
Didn't he have some weird bean phobia or something
He had a
too?
thing about beans we
Yeah.
may never know. I'll get into beans in a second. He did get around, though. I mean, he started his traveling with his father. He went around to Egypt, to Babylon. Think how far that was in 500 BC. Where everywhere you went, you had to go by boat or walk. And to walk from the parts that they could get to by boat, which was on the Mediterranean, to Babylon meant crossing Saudi Arabia, or was now Saudi Arabia. So you had to cross the desert to get there. Maybe he took a northern route through the Fertile Crescent. Somehow he managed to get all the way to Babylon. He came back with a knowledge of Babylonian arithmetic and the degrees, minutes, seconds system of numeration. He eventually settled in Italy, and that's Croton. I have to check on this again, but I think Croton is in what's now Sicily. The island is off the boot. Do you know?
Crotone.
Crotone.
Yes.
Is it in Sicily?
Yes.
So he creates this cult-like thing. Their motto was Everything is numbered. That, of course, I agree. You know, they thought that literally the physical stuff around us was a reflection of number. So much the way we think everything is quarks and leptons and protons and neutrons and that kind of stuff, they thought there were numbers down inside that made reality. And, you know, it's probably no crazier than any other belief system. I love that he named his inner circle the mathematical. This is the first place that I know of the name of our subject, mathematics, comes from. I'm sure it's a similar root anyway. He had another outer circle of guys sort of like Hitler's brown shirts and sort of muscle. But the inner circle were vegetarians, and they would not eat beans.
When I eat what?
Beans.
Beans?
Beans. Frijoles negros?
Yeah,
Right?
why?
It's my favorite thing. I have no idea. Nobody knows, but they had a rule against eating beans. Now, if you're a vegetarian, protein is kind of hard to come by, and beans are one of the really good sources of proteins from the vegetable world. So the fact that they were vegetarians and also did not eat beans, I think they were all malnutritioned. You know, they're probably not in good shape. I don't know if their interpretation of vegetarian meant they could have fish, because then that would be a protein source. They do talk about them all going out on sailing trips together. Okay? Yeah. I think so. Because one person at least writes about them, describing them more like beings, and they respected life too much to eat living things, and they didn't count plants as being alive.
Good, wide enough that you can, have a lot of
Yeah, we don't know why they refused to eat.
Yeah, but it can't be something that's a problem because I have a lot of stuff on the so like the American Revolution.
I think there was one theory. One theory is that they thought the spirits of their departed brethren would go in and inhabit a bean plant. And so, you know, if you were eating, it would be like eating. The other thing is, and this is, I'm sorry that I have to say this, fine ladies, but it looks like nuts. Well, I mean, nuts. So maybe just the physical appearance of it was like, yeah, we shouldn't be eating those. EOE, everybody know what an EOE is? Equal Opportunity Employer.
Then there was this
These people did not have sexism. Women were perfectly welcome in their inner circle. Isn't that cool? Because that has not been the case for the last 2,000 years of mathematics. It's been really hard on women in mathematics. It's starting to be different today, but in the very beginning, Pythagoras had several females in the inner circle. The outer circle was called the Kakustoi. And yeah, I mentioned this society became very political, and they tried to get their views dispersed through the world, and then the central government there started seeking out the leaders and having them killed. Wait, I got to tell you the one thing that's really hilarious. A lot of people think the reason Pythagoras died is people had gotten him away. Death squad is coming to kill Pythagoras. They got him away and they're running away from the death squad, and they come across a field of beans. He's like, I'm not crossing that field of beans. I'm not doing it. So they waited there while the came. There's a famous painting of this scene of Pythagoras shying away from the field of beans while guys with swords are running at him. He did not Pythagorean theorem. I know this guy's There's a lot that he did do, though. This secret society studied arithmetic, music, geometry, and astronomy. And those four areas make up what's called the quadrivium. So that's the root of the liberal arts. You know, of course, we call the liberal arts university, or we're at school liberal arts. Now, liberal arts are those four things. There's also the trivium, which the word implies to you that they thought these things were trivial. They didn't have formal logic, they just had a sort of trivial version of logic like kids in grammar school right now. No, I use the word grammar school. What is grammar really? No, just knowing how language is constructed. And then rhetoric. That's interesting to me. When they studied rhetoric and they considered it a trivial topic. Because rhetoric is studying how to express yourself effectively to others, how to convince other people what you're thinking. So those things, the trivium, logic, grammar, rhetoric, and then quadrivium, arithmetic, music, geometry, astronomy, those are the liberal arts. Check out how many of those are actually math. Arithmetic is certainly math. Geometry is certainly math. The way these guys did music, there was a lot of math in it. And astronomy, at that time, it was hard to tell an astronomer from a mathematician. And then I was in there was clearly a heavy influence. I will skip down to the end here. I'll tell you, we've got to get to this story about that.